Okay, section 3, chapter 6, we'll call this like part 2. Really piggybacks off the last video talking about multiple angles in degrees. We're just going to convert this into radians. So, same thing. Last one started off with an inverse tangent. This one's going to start off with an inverse cosine. So I'll take the inverse cosine of both sides and so the inverse cosine of -1, and I'm going to my unit circle, and I find the x value of -1 happens to be at pi. So 3 theta is equal to pi. If I want to solve for that, I'm going to divide by 3 or multiply by 1/3 and get theta is pi over 3. Now, in general, I would go pi over 3 plus 360k because the period in cosine is a full revolution of 360 degrees. But in terms of radians, that's going to be 2 pi k. Well, if I take that and divide by 3, my full circle, my full period or full revolution is no longer 2 pi. It's now 2 pi over 3 or 2/3 pi. So if one of my angles of pi over 3 fits in this range right here, if I add 2 pi over 3, that puts me at pi, which is also in that range. And if I add another 2 pi over 3, I end up getting 5 pi over 3, which is also within that range. I'm pretty sure if I go up one more, that gives me 7 pi over 3, but that's bigger than 2, and I'm going to cut that off. And these are my 3 possibilities for this function in a revolution of 2 pi, or in one full circle, 2 pi. Okay, same idea. I'm going to take the inverse cosine. Okay, now I'm going to keep in mind with my inverse cosine when I'm solving this, I'm going to get my reference angle for the square root of 3 over 2. Okay, the inverse cosine of square root of 3 over 2. And that reference angle is going to be 30 degrees, or in radians, pi over 6. Now, since I have a cosine that is negative, cosine is negative in quadrant number 2. It's also negative in quadrant number 3. So in quadrant number 2, here's my reference angle of pi over 6. Sorry, I wrote that and it kind of went away. So to get me a full pi would be half of the circle. Pi minus pi over 6 is 5 pi over 6, so that's in quadrant number 2. In quadrant number 3, that would be taking pi plus pi over 6. So pi plus pi over 6 would be 6 pi over 6 plus 1 pi over 6, or 7 pi over 6. There's in quadrant number 3. Okay, again, I am taking 2 of the x is equal to 1. It's going to be 5 pi over 6 plus 2 pi k. And another one where 2x is equal to 7 pi over 6 plus 2 pi k. I'm going to think of it as multiplying by 1/2 instead of dividing by 2. It's going to help me out when I am working with these fractions within fractions. So this becomes 5 pi over 12. Okay, and then if I divide that by 2 or multiply it by 1/2, I end up getting plus pi. Okay. Same thing, I'll multiply by 1/2 on there. Come on, guy, would you stay with me here? So that's going to give me x is equal 7 pi over 12 plus pi k. Okay, now we're working within the full circle. So if I took 5 pi over 12 and I added pi, which would be 12 pi over 12, that gives me 17 pi over 12, which is 1 5/12, smaller than 2. I'm pretty sure if I added another pi, I'm going to go over. So there are 2 values of x because of really me starting off with a reference angle or being in the second quadrant. Okay, and then I'll do the same thing. I'll take 7 pi over 12 and I will add 12 pi over 12, which is basically 1 pi. And that's going to give me 19 pi over 12. which that means really that it's 12 and 7, 12. So, and I'm pretty sure if I add one more, I'll go over. So there are two more. And there are two more in radians to figure out the multiple angles.